Welcome to the MCS video presentation on controlling a process system. Let's first discuss the system description. The system hardware assumptions are there will be two circuits, each with a 25-ton scroll compressor. There will be 4 condenser fans per circuit, a liquid line solenoid on each circuit, and we will be using 407C refrigerant. There will be a standard TXV control on each circuit. The control assumptions will be chiller in at 16 degrees centigrade, chiller out at 9 degrees centigrade. The process target will be 25 degrees centigrade plus or minus a half a degree centigrade. There will be a modulating valve to control the process temperature. Looking at the system configuration, we'll look at the relay output points first. You will notice that it is a standard chiller type setup. We have compressor 1, liquid line 1, compressor 2, liquid line 2. Those are the relay outputs that are controlling the compressors. Then we have an evap pump and also now a process pump. You have the standard warning alarm system outputs, and then we have the condenser fans for circuit 1 and the condenser fans for circuit 2. Okay, looking at sensor inputs, we will have chiller in and chiller out for controlling the chiller. We will have suction pressure, discharge pressure, amp draw, and suction and discharge temperatures, all for circuit 1. We will have the identical information, suction pressure, discharge pressure, amp draw, suction temperature, and discharge temperature for circuit 2. There will be a flow switch, a run stop switch, emergency stop, and a phase loss input. The next set of sensor inputs will be the process temperature in and out, and this will be where we are controlling on the process out temperature. There will also be process pump in and out pressure, and this will be used to tell us whether there is flow and that the process pump is in fact operating. We will also have evap pump in and out so that we can determine the flow for the evaporator section. Then we will have condenser pressure out and condenser temperature out, which will enable us to calculate subcooling. Then we will have a digital disable switch 1 and 2 that will allow us to disable either circuit if we want to work on one. The next section is sensor inputs, but these are virtual inputs. That means they are not physically wired to any input, but they are part of the system and allow us to collect this information so that it can be stored and graphed at a later point. The first two are subcooling, and we will calculate those. Then we will pull in the information for the suction superheat, and we will pull in the information for the discharge superheat. There will also be an analog output, which will be the process valve and the percentage of where we are. Okay, this analog out will control the process. If we look at the evaporator portion of the HVAC section for the configurator, on the left-hand side are all the normal things that we will do with the chiller, and on the right-hand side you will see the process control part. And in here we will have the relay output for the process pump, the analog output for the process valve, the sensor input pointing to the process temperature out. We can have additional information for pressure coming off of the pump, and we can also have a fault for the VFD. Then there's a second column on the right that allows us to put in an entire second pump if we have duplicated the pumping system. Okay, there are 5 process control set points. And what they are the process target, which in this case we have set for 25 degrees C. There is the zone that we are going to allow it to operate in. So we are telling it we want it to be 25 degrees C plus or minus a half a degree. Then we have a process delay that says you are to look at the system every 2 minutes or 120 seconds and make a decision whether we need to open or close the valve to maintain the process target where we have set it. There is also an overriding set point called rate of change. This is actually the slope of the line of the process target temperature. And if we exceed more than that value, then we are telling the system if we're moving in the right direction to hold so that we don't overshoot the target either above or below. And the last set point, 150, is the minimum percentage that we're going to operate the valve at. So as a summary to process control, it is a standard HVAC Magnum software. It will handle both the chiller and the process. The process can handle dual pumps. All of the standard options with config and connect are available. If you have any questions, please call Microcontrol Systems at 239-694-0089. Thank you.